Hey guys, these notes are going to go over solving 1 and 2 step equations. This is something that you guys have gone over in middle school, but it is good a refresher before we actually start algebra because a lot of our equations that we do end up solving are going to take many steps, so it is important that we know how to solve those 1 and 2 steps. So our essential question is, what are the steps for solving a linear equation? Now on the very last page, I'm going to go over the steps that you can use to help you solve an equation. However, eventually you're going to get so great at solving equations that you won't even have to look at the list, and typically students don't ever look at the list, but it is there in case you guys do want some steps listed out for you to help you solve. So we're going to go over some vocabulary. And the first thing I'm going to go over is solve. So what does it mean to solve something? Well, to solve something is to find the solution. If I ask you to solve a problem, I want you to find the solution to the problem. So what's the solution? Well, most of the time you'll say, well, it's the answer to the problem. Well, what does that mean? Well, the solution is the value. Let me fix my handwriting a little bit. The value of the variable. So usually when you solve an equation, you'll get like x equals 5 or z equals 17. So the equation is saying whatever that number is that's the solution to that equation. And we'll talk about checking our answer and what that means. But it's the value of the variable that makes the equation true. Okay. So for example, x plus 3 equals 5. The solution to this equation would be x equals 2. Why is that the solution? Because in order to make this equation true, x must be equal to 2, because 2 plus 3 equals 5. So that's the solution. All right. Now, term. Now, term is something that you probably haven't heard of. I've tried not to use this word with you because you don't really know what it means yet, so we're going to actually go over what that means today, and it's going to be really important when we get to our lessons over polynomials where we talk about a lot of terms. But a term is either a number, a variable, or both, really, or both, that is separated by plus or minus signs. Okay, now I'm going to actually give you some examples on what this means. And again, when we're talking about polynomials, we'll actually go over, and that's probably a brand new word for you, but we'll go over actually what terms are and all those examples. But I'm going to give you a few examples so that you understand what terms are, because I will refer to them as terms. So for example, 3x minus 5. This is an example of something that has two terms. Remember that terms are numbers, variables, or a mixture of both. So this little expression here, not an equation, is actually two terms. Now, why is this two terms? Remember, I said that it's separated by plus or minus sign. So this is what's separating them. So I have one term over here and another term here. So in this case, this would be two terms. One of my terms is 3x, and the other term is 5. They are separated by a minus sign. Here's another example. 5x plus 2 minus 3y. How many terms do I have here? Here I have three terms, 5x, 2, and 3y. There are three terms here because they are separated by plus and minus signs. So the plus and minus signs are separating our terms from each other. So this would be three terms. All right. So then we'll move on to a like term. A like term are things that we can actually combine together because they are the same. So these are terms that have the same, an emphasis on same, variable and exponent. Like terms can be combined if they're exactly the same. So for example, I'm going to give you some. 2x and 5x. These two are exactly the same. or their variables and their exponents are the same. So here, their variables they're both the same. They both have an x variable. And also, they both have the same exponent. Now, we haven't really talked about it that much, but if the exponent is not written, it is understood that there's technically a 1 there. We just don't write that 1 there. So they have the exact same variable, the exact same exponent. So that means we can actually end up combining them. And I kind of talk about it like it's objects. So for example, if I wanted to add them, right, 4x plus 5x. If I have 4 apples and I want to add 5 apples, then I would have in total 9 apples. But in math, we don't say apples. We say x, or we use a different type of variable. So 4x plus 5x is going to give me 9x. I'm only allowed to combine them because they have the same exact variable and the same exact exponent. But if I wanted to add 4x plus 5y, for example, I cannot combine those. They do not have the same variable. They are not like terms. It is impossible. It does not make 9xy. That is not allowed, okay? So it has to have the same variable, same exponent. Another example of like terms would be 7y squared and 4y squared. Now, it doesn't matter that the number is different because that's just telling you the quantity, how many you have of that variable. So for example, 3x plus 6x, I have 3 x's and I want to add 6 x's to that. In total, I have 9 x's. I can combine them because they're the same. So here, even if I wanted to add 3x plus 3y, I still couldn't because their variable's not the same. It does not matter what that number is in the front. And just a reminder, that number in the front is called a coefficient. So it does not matter what the coefficient is. The coefficient here is 7, the coefficient here is 4, but it doesn't matter that they're different, as long as their variable is the same and their exponent is the same. In this case, these are like terms because they both have a y and they both have an exponent of 2, so they are like terms. So if I wanted to combine this, I could. So if I wanted to do 7y squared plus 4y squared, that would give me 11y squared. So if I have 7 of these and 4 of these, in total I have 11 of these. All right, so that's some vocabulary for us. And then we're going to talk about what it means to solve. So an equation always has 2 sides. So when you're solving for something, there's always 2 sides. So you think of it like a scale, okay? You have to keep it balanced. You must always keep it balanced. And in order to keep it balanced, you do the same thing to both sides. Oops. So you must keep it balanced by doing the same thing to both sides. Anything you do to one side, you have to do to the other. It's like when you go to the gym, you don't pick up a 50-pound dumbbell and a 5-pound dumbbell and work out with each arm separately because one of your arms would end up getting way bigger than the other one. So you want to keep things balanced, and you would do the same thing to both sides to keep it at balance and equilibrium. Now, to get rid of something, so if I want to move something from one side to the other side, I have to do the opposite operation. And this in middle school, they might have called this the inverse operation. You would do the opposite. Okay? So if I wanted to move a positive 5 from one side to the other, I would have to subtract because that is the opposite. So I want to get rid of it by doing the opposite. Okay, what's the goal here? Well, the big goal that I'm trying to do when I'm solving an equation is to get the variable by itself. And I'm not going to say get x by itself because, I wrote x on accident, because sometimes it's not x, sometimes it's m, sometimes it's t, it just depends on the problem. So your goal is to get that variable by itself. If it says to solve, that's what you're asked to do. So we're going to go ahead and start off with some review of one-step equations. So again, obviously, the answer here is, okay, 2 plus 5 makes 7. But we got to show our work algebraically. Now, in middle school, you might have done a thing where at the equal sign, you drew a little wall so that you could separate your sides from each other. I'll go ahead and do that for the first couple of problems, but I'm not going to do it for the rest, just because we're moving up a little bit, so you guys should be able to differentiate between that. If you want to draw a line on every single problem on your equal sign, that is okay with me if it helps you prevent making mistakes. So if you want to draw a line, you may do so. So I'm going to go ahead and draw a line for this problem. Now, the goal here is to get x by itself. Yes, I know the answer is 2, but we have to solve and show work. So how do I do that? Well, If I want to get x by itself, what's prohibiting x being by itself? Well, it's having 5 added to it. If I want to get rid of that plus 5, I have to do the opposite. So I would have to do the opposite and subtract 5. Now, what happens when I subtract 5? Well, 5 minus 5 is 0. So it ends up canceling. It goes away. I've gotten rid of it. So is that it? Do I just do that? No. In order to keep an equation balanced, I must do the same thing to the other side. So I also have to subtract 5 from the other side as well. So anything I do to one side, I have to do to the other. If you forget to do it to the other side, your equation is not balanced, and your answer at the very end will be incorrect. So what's left that I have on this left side here? The only thing I have left is an x equals 7 minus 5 is going to give me 2. So my answer is going to be x equals 2. All right, number 2. I have 3x equals 18. The goal is to get 18 or x by itself. So how would I do that? Well, what do I notice here? 3 is attached to x by the operation of multiplication, 3 times x. I want to get x by itself, but I have to do the opposite to get rid of that 3. Because the 3 is being multiplied currently, I have to do the opposite and divide by 3. So I have to do the inverse or the opposite operation. And if I divide by 3 on one side, I have to divide by 3 on the other side. So 3 divided by 3 over here is going to give me 1x. Now, 3 divided by 3 is 1. But do we really need to write 1x? We don't have to. If you want to write 1x, that is okay. But typically, we don't ever write 1x. We just say x because we're understood that there's only one of them there if we just leave it as x. Equals 18 divided by 3, which is going to be 6. All right, moving on to number 3. Now, I'm not going to draw the line anymore, but I am going to continue solving this. So, again, we have x divided by 5 equals 4. Well, how do I get rid of that 5? Well, right now, x is being divided by 5. In order to get rid of the divided by 5, I must multiply both sides by 5. So if I times both sides by 5, and technically you're multiplying by 5 over 1, right? 5 as a fraction is 5 over 1. So I'm going to multiply both sides by 5, but I'm going to go ahead and write 5 over 1 here, okay? And then that means I'm going to have to multiply the other side also by 5 over 1. Why am I multiplying? Well, x is being divided by 5, and I have to do the opposite. So let's go ahead and start here. 5 times, if I multiply 5 on this side to the opposite of dividing by 5, they actually cancel out each other. And you're like, well, I don't understand what's going on. Let's simplify this in a different way. Okay, 5 over 1 times x divided by 5. I can multiply across. 5 times x is 5x. 1 times 5 is 5. And then the question is, what is 5 divided by 5? Just 1. So it'd be 1x or just x. So that 5 ends up canceling. So that's the long way of doing this. Really, all we're doing is, hey, I notice that it's being divided by 5. I'm going to go ahead and now multiply by 5 so they'll cancel, and all I have left on this side is x. And then on the other side, I had to do 4 times 5 over 1, or 5 really, and that equals 20. Moving on. Two-step equations. We're going to first review the order of operations, which we did review over 8th grade some skills. We might have reviewed some over order operations. So I'm going to go ahead and put that down here. So our order of operations is PEMDAS. Okay. So P stands for parentheses, exponent, multiplication, division, addition, subtraction. All right. And I noticed that all of my stuff slowly started merging over to the right. That happens when I write sometimes. I don't know why, but bothers me a little bit. All right. So these are our order of operations, and we want to make sure that we remember that with division and division and multiplication, that it's whichever comes first, left to right. go ahead and copy this as well. Paste it down here with addition and subtraction. So the exact same rule applies here. Whichever comes first, left to right for addition and subtraction as well. All right, so when we are solving equations, right? So when we review PEMDAS, we're just simplifying. But when we're solving equations, the order of operations is actually the opposite. Okay, so really, we're actually starting on the addition and subtraction side rather than starting at parentheses, okay? So let's go ahead and start. And I want to emphasize on the opposite because we do tend to forget that it's opposite. We want to make sure we do remember it's opposite. All right, so with number 1, again, I am going to start off with drawing a little line down, and then we'll start. And actually, I'm going to use a different color. Let's do pink, and then we'll work with yellow. Or orange, whatever. All right, 8x minus 5 equals 11. Now, the backwards of PEMDAS means I start with addition and subtraction first. So obviously, I see that there's an 8 on on this left side, so x needs to be by itself, the variable. There's an 8 over there, and there's also a negative 5 over there, a minus 5. And also, by the way, negative 5 and minus 5 are technically the same thing. I'm not really sure why they teach it as 2 separate things early on, but they're really just the same thing. That's why in your calculator, the minus sign and the negative sign are technically the same. Okay, except for on a graphing. We want to get the x by itself. The question is, do I get rid of the 8 first, or do I get rid of the 5 first? Well, PEMDAS backwards says I start with addition and subtraction. So is there anything that I can add or subtract to the other side to get rid of something before I divide or multiply to get rid of something? So the first thing I notice is I could divide by 8, or I could add 5. But which one do I do first? You want to add 5 first. You do PEMDAS in reverse order. So here I would add 5 to both sides. And why do I do it to both sides? Because anything I do to one side, I have to do to the other side. So that's going to cancel. It cancels because negative 5 plus 5 becomes 0. So what I have left on this left side is 8x. And then I have 11 plus 5, which is 16. So now what do I do? Well, 8 is connected to x by the operation of multiplication. Because they're being multiplied and I want to get rid of it, I will do the inverse or the opposite and divide. So I would actually divide by 8 here on both sides. Again, both sides is a key word. 8 divided by 8 cancels. I get 1 technically. So x equals 16 divided by 8, which is 2. Now, how do I check this? Now, I'm not going to ask you to check it really that often. However, I do want to show you that you can check these problems. So let's check. 8x minus 5 equals 11. And I'm going to go ahead and put this down here. I'm going to check 8x minus 5 equals 11. And I'm checking to see if x really equals 2. So let's check this. If x equals 2, let's see if x is truly 2. So what I'm going to do to check this is I'm going to plug it in for x here. Now, do I just write 82? Oh, whoops, hold on. Do I just write 82? Is that what I write here? No, I'm saying that I'm plugging in x. I'm plugging in 2 for x, and they're being multiplied. So what I want to make sure is when I do 8, I want to put parentheses where that 2 is. Anytime I plug in, I always use parentheses. Emphasis on always. You will do this for the rest of algebra and the rest of geometry. Anytime you plug something in, you always use parentheses. I'm going to go ahead and continue writing this. So the goal here is to check to see if this is true. Remember that the solution, the definition of a solution is the value of the variable that makes the equation true. So let's check to see if the solution is really 2. So 8 times 2 is 16. And then with minus 5 equals 11. And then if we keep simplifying, 16 minus 5 is 11. Does 11 equal 11? Yes. So this is correct, and we've checked, and it's all good. All right, moving on to number 2. Now, this one is a little bit different from the previous one. What's different about this one? Well, here I notice that there's two terms that have variables. There's a 9m, and then there's a 4m. So what you want to do before you ever start is you always check to see if you can simplify anything if possible. And I notice that I can actually combine 9m and negative 4m. So the goal here is I want to combine my like terms. If I have 9 D's and I take away, oh not D's, M's, sorry, I'm looking at my previous notes. If I have 9 M's and I take away 4 M's, I now have 5 M's left over. And then everything else stays exactly the same because I haven't done anything with them yet. So I'm combining my like terms there. So now I'm going to solve my equation like normal. The first thing I would do is I would add 2 to both sides. Okay? Remember, anything you do to one side, you have to do to the other side. And the reason why I'm adding 2 first instead of dividing by 5 is because I have to do addition and subtraction before multiplying and dividing. All right, so negative 2 plus 2 becomes 0. So then I have 5m equals 20. 18 plus 2 is 20. And then my next step here is I want to get the m by itself. In order to get the m by itself, I would divide by 5, because I would do the opposite operation, because right now it's being multiplied. 5 divided by 5 is 1. So I have 1m equals, again, you can write the 1 if you want, 20 divided by 5, which is going to be simplified to 4. So m equals 4. And the question is, how do I check it? The same way you checked the last problem. 9m minus 4m minus 2 equals 18. Anywhere I see a variable, I want to plug in the variable to check. So I would actually plug in the variable in 2 spots. I would plug it in here and here. So then I would have 9 parentheses 4 minus 4 and then parentheses 4 again. Remember, anytime we plug in a number, we want to use parentheses. Now, where'd that 4 come from? Well, I'm checking to see if 4 is the solution. That's why I'm not plugging in like 3 or something. And then I'm copying literally everything exactly the same. So everything in orange stayed exactly the same, except I'm replacing that m with the number 4. And now we're going to check to see if this is true. 9 times 4 is 36. Negative 4 times 4 is negative 16. And then we have minus 2 equals 18. So let's keep simplifying. 36 minus 16 is 20. And then 20 minus 2 is 18. And then 18 does equal 18, so this is correct. Again, will I have you check on every single problem? No, I'm just showing you that you are able to. Moving on to number 3. 5a plus 4, or not 5a plus 5a plus 3, parentheses a minus 2 equals 26. All right, now this one's different from the previous one because there's parentheses here. How do I get rid of parentheses? And you're like, whoa, you just told us that we shouldn't mess with parentheses first because PEMDAS says we shouldn't. Actually, PEMDAS says check inside the parentheses. Can you simplify what's inside? If I look at this, I have a minus 2. Can I take a minus 2 and can I simplify that really to anything? No, because I have no idea what a is. Like a could be 5, a could be a billion. I have no idea what a is, so I can't really say a minus 2 equals 7. That doesn't work. So really, the parentheses here, we're not trying to simplify them, we're trying to get rid of them. So here's the notes for you. In order to get rid of parentheses, you want to distribute. Now, what does it mean to distribute something? Well, distributing something means I'm taking the number on the outside and multiplying it in. Now, distributing is the operation of multiplication, okay? When we're distributing, we are multiplying. I point this out because sometimes when people distribute, they actually add the numbers rather than multiplying them. So the first thing I'm going to do is I want to get rid of those parentheses because they're scary and nasty. So this is what I'm going to do. I'm going to be like, okay, well, I want to get rid of the parentheses around a minus 2. So how would I do that? I would take the number attached directly on the outside of those parentheses. I would not distribute the 5a. That is not how this works, okay? Not the number on the very far outside. It has to be the number directly attached to the parentheses. In this case, the 3 is directly attached. So I'm going to do 3 times a. Well, 3 times a is just 3a. 3 times negative 2 is negative 6. 3 times negative 2. We're not adding them, okay? Now, I haven't done anything else to the other terms. Now, this is a positive 3 because there is a positive sign there. So I'm going to go ahead and leave everything else as is. I'm going to drop everything down. So the only thing I've done here is I've gotten rid of those parentheses, and now I can move on with simplifying. Well, what do I notice? I notice I have like terms, so I want to go ahead and combine these. 5a plus 3a is 8a. Okay, now my next step here is I'm going to add 6 to both sides. I want to do the opposite. Because it's a minus 6, I'm going to do the opposite by adding it. Negative 6 plus 6 becomes 0, so they cancel. I have 8a equals 26 plus 6, which gives me 32. Okay, and if I forget to add to this side, I'm going to end up with 26, so make sure you do the same thing to both sides. If you add 6 to one side, you have to do it to the other side. That's only if you're moving things from side to side. Now I want to get a by itself, so my next step here would be to divide by 8 because it is being multiplied to a currently. So a equals 32 divided by 8, which is 4. And how would I check this? I would go to the very beginning, plug in 4 anywhere I see an a, and then simplify to see if my equation signs are or if my products or my items on each side are equal to each other. Moving on to number 4. 30 equals k minus negative 5. Now, what do we see here that we don't like? Parentheses. So how do you get rid of parentheses? You want to distribute the number that's directly outside of them. Now here, is there a number directly outside of these parentheses? No. But remember I told you if it's not written, what is really there? There's really actually a 1 here outside the parentheses, we just don't write it, okay? So let's go ahead and distribute. And when you distribute to every term inside the parentheses. So here, how many terms were inside those parentheses? There were 2 terms. That's why I have 2 distribution arrows. Here, how many terms are inside this parentheses? Just negative 5. That's the only thing inside there. And you're like, well, isn't there like a magic 1 in here? No, not really, because if there was a 1 in there, then they would have just wrote 1 minus 5. So the only times that they don't ever really write a 1 is if it's attached directly in front of something, so if it's attached or if it's an exponent. Okay, so let's distribute negative 1 times negative 5. And actually, I'm going to use a different color because it looks like I used red above. So I'm going to use green. Negative 1 times negative 5 is positive 5. Okay? And then I'm going to leave everything as is. So 30 equals k plus 5. So I left the 30 equals k the same, but all I've done is gotten rid of the parentheses. So how do I get k by itself? Well, in this problem, usually our variable is on the left, but this time it's on the right. Does it really matter which side it's on? Not really. The goal is still the same, get the variable by itself. So how do I get k by itself? Well, I would get rid of that 5, and I would do that by subtracting 5 from both sides. Because it's being added by 5, I'm going to subtract 5 on both sides. So 30 minus 5 would be 25. So k equals 25. Again, it might look funny to you because k is on the right side. But if you really wanted to, you could technically write k equals 25 like this, and that is also okay. It doesn't really matter the order because you're still telling me the answers or the solution is 25. Moving on to number 5, 5 minus 7, parentheses x minus 3, parentheses plus 2x equals 6. Now I do want you to try to do this one if you want to go ahead and pause the video and be like, hey, I'm going to try this one. Worst case scenario is, hey, you make a mistake and when I go over it, and you just have to erase it. It's not that big of a deal. Okay. So I'm going to go ahead and begin. So hopefully you've paused it if you wanted to try it. So what's the first step here? Well, I see parentheses. Let's go ahead and get rid of those, right? Let's get rid of these parentheses here. How do I get rid of the parentheses? I want to distribute the number directly attached by multiplication on the outside of those parentheses. So I am not going to distribute the 5. I'm going to distribute the negative 7. Remember, and why is it negative 7 and not just 7? Well, remember the sign goes with it. So there's a negative attached to the outside of that. Negative 7 times x is negative 7x. Okay? I would not distribute the 5 here. So the most common mistake is people distribute the wrong number in. And remember, distributing is multiplication. And we have negative 7 times negative 3. And that is positive 21. All right, so now I'm going to go ahead and rewrite everything on the next line exactly the way it is. So the 5 in the front, I didn't do anything to that 5, plus 2x equals 6. All right. Okay, so let's see what we can do next. Well, I could combine like terms. So what do I notice here? Well, I notice that I have x's that are the same. We have negative 7x and then positive 2x. All right, well, how can I combine those? Negative 7 plus 2. You just type it in the calculator like you normally would, but I'm going to go ahead and write down 5 here. And I'm going to go ahead and combine those. Negative 7 plus 2 is going to be negative 5x. If I have negative 7 and I want to add 2 to that, it becomes a little bit more positive, but it's still negative 5. And then I'm going to go ahead and say plus 21 equals 6. Now, you're like, well, how come you put the x in the middle? Like, the x wasn't in the middle before. It doesn't really matter the order as long as you keep the signs the same. So really, you could have written it like this also. 5 plus 21 minus 5x. That is also exactly the same. You just don't have to keep it in the same order. Just make sure the signs are attached correctly. All right, so I combine those like terms, but then I also notice something else, and I don't know if you're noticing it too. I actually have another set of like terms, and those like terms are just regular numbers. 5 and positive 21 are actually like terms. How are they like terms? Well, they're both regular numbers. I can combine them like I normally would. What's 5 plus 21? 5 plus 21 is 26. So again, they're like terms because they're exactly the same. They have the same variable, same exponent. 5 and 21 are like terms because they have the same variable. Their variable is that they don't have one, and they have the same exponent on that variable, which is the one that they don't have. So they're exactly the same. 7x and 2x were the same variable, same exponent, so I could have combined them. So now I have 26 minus 5x equals 6. Okay? Goal, again, is to get the variable by itself. So here's the question. What do I do first? Most common mistake I see is that we want to add 5 to both sides. And we don't want to do that. Why don't we want to do that? Because is 5 being connected to x by addition or subtraction? No. The negative 5 is attached to x by multiplication, so we have to be super careful with that. Can I add or subtract anything before I multiply and divide? Yes. This 26 in the front is a positive 26. I want to get rid of that. I want to get rid of anything that's around my x before I actually multiply and divide really anything. So the first thing I'm going to do is I'm going to subtract 26 from both sides. Why am I subtracting? Because it's positive and I'm doing the opposite. So that's going to go away. So then I have negative 5x equals, well, 6 minus 26. 6 minus 26, well, 6 minus 26 is negative 20. So again, 6 minus 26 is negative 20. These positive and negative signs can get really tricky if you're not super careful with them. All right, now how do I get x by itself? Now that 5 in the front is connected by multiplication. It is negative 5x. So in order to get rid of negative 5, I'm going to have to divide. I'm doing the opposite. Okay, so negative 5 divided by negative 5 is 1. So I'd have 1x equals negative 20 divided by negative 5 is going to be positive 4. And again, I could check this by plugging it back into the original problem and checking to see if it is equal or true. Now we're almost done. We have about just 1.5 pages. That last page is just the steps. So really, we only have a few problems left. So we're almost done. So number 6, negative 20 equals negative 2 parentheses 10 minus 4h plus 2h. Now I have notes on this side. I hate writing, so if there's ever a section for notes, it is very important. Okay, so we're going to go ahead and start. First goal is get rid of those parentheses. We don't like them. So we're going to distribute to get rid of the things in the parentheses, and you distribute the number directly attached. And remember, distribution is multiplication. Negative 2 times 10 is going to be negative 20. Negative 2 times negative 4h is positive 8h. A negative times a negative is a positive. I'm going to go ahead and bring down everything else that did not change, that I did not mess with yet. The next thing I'm going to do is combine any like terms if there are any. If they're not, then we're good. But if there are, then we're going to go ahead and combine like terms. 8h and 2h are like terms. 8h plus 2h makes us positive 10h. Okay, goal here is still to get the h by itself. Well, how would I do that? I don't want to go ahead and divide by 10 yet. We don't want to do that yet. We want to add or subtract if possible. Well, I noticed that there's a negative 20 in red over there. How do I get rid of that and move it to the other side? I'm going to add it to the other side. I'm going to add it to one side, so I have to add it to the other side. Well, what do we notice here? Negative 20 plus 20 makes 0. It goes away. So what I have left on that side is 10h on my right side. Then on this side, what do I have? Negative 20 plus 20 equals what? 0. Okay, so then I have 0 equals 10h. And a lot of people end up stopping here. They tell me like, hey, no solution, this is impossible, you can't keep doing this. That's not really true because we actually haven't technically finished. Did you get h by itself yet? No, it is not by itself. You cannot claim that you cannot keep going. So, how to get rid of the 10 that's attached to the h? Well, they're connected by multiplication, so I do the opposite by dividing by 10. 10 divided by 10 is 0. Whoops. 10 divided by, not 10 divided by 10 is 0. 10 divided by 10 is 1. Oof, big mistake. Okay, 10 divided by 10 is 1, so I just have 1h. And then I have 0 divided by 10. The most two common answers is I get no solution or the answer is 0. So how do I check that? Well, 1, you can always just type it in the calculator. 0 divided by 10 is going to give me 0. But here's another trick, and here's where the note comes in. So h is equal to 0. Is it possible for a solution to be 0? Yeah, it just means if I plug in the number 0, that makes my equation true. This is possible. This is a real answer. You can have 0. It is allowed. So here are our notes. And here's a way to remember when you have no solution versus a solution. So if I have 0 divided by 1, okay? So if I have 0 on top over 1, again, 0 divided by any number is going to give me what? Really 0. Let me go ahead and type these into Desmos. Okay, so I have 0 divided by 8 equals 0. Let me go ahead and put on projector mode so you guys can see a little bit bigger. How about 0 divided by 15? What about 1,000? Doesn't matter, right? It doesn't matter what that number is on the bottom, so I'm going to use 1 for a placeholder because it's easy. If I have 0 divided by 1, it's going to give me 0. However, if I have 1 divided by 0, let's try that in Desmos. 1 divided by 0, undefined. How about 5 divided by 0? Undefined. How about 1 million? That's 10 million divided by 0. Still undefined. So it doesn't matter what number is on top, so I'm going to use a 1. 1 divided by 0 is actually undefined. So what does that mean? I get an error, right? Usually the graphing calculator will say error. You can't divide by 0. So what this means is if I have 0 divided by 1, that is okay. It's allowed. You can get a number, you get an actual number in the calculator, and you don't have a weird error. However, if you have 1 divided by 0, it's not okay, and you get an error. Okay, so no for not okay, and then okay if you have 0 on top. So that's just a trick that I show students. We don't have a ton of students that use it, but it actually has become helpful for some of them to remember. If you have 0 on top, keep going. You can get 0 as your answer. In this case, I had 0 on top here, right? 0 divided by any number is okay. But if I have 0 on the bottom, in the denominator, it's not okay. So again, this problem gets a lot of people because they're like, hey, I get h equals 0, no solution, undefined, doesn't work, which is not really true. All right, so we have 2 special cases that I'm going to go over, and they're called special cases because the answer that you get is not a number answer, really. So let's go ahead and go over number 1. 3x equals 3 times x plus 4. Okay, first thing I notice is I see parentheses, so I'm going to go ahead and get rid of them by using distribution. So if 3x equals 3 times x is 3x, 3 times 4 is 12. And I'll go ahead and make these black just so you know that they were the original, that I haven't done anything to those. Now, I want to get, now, I always tell you to combine like terms if possible. Now, you can only combine like terms if they're on the same side. Here you'll notice that I have x's on opposite sides, so I can't really combine them because that'd be illegal. I can't just be like, oh, together they're 6x. I can't do that because they're on opposite sides. In order for them to even be combined, I have to move them to the same side. So the question is, do you want to move this guy to the left, or do you want to move this guy to the right? Now, typically, I like to keep my variables on the left. So I'm going to go ahead and move this over to the left. And another thing is, the x is already by itself on this side, so it's good to just move everything to the left. Again, I like to keep variables on the left, that's why I'm doing this. So, how do I get the 3x to move to the other side? Well, if I have a positive 3x and I want to move the entire term, I have to move both the 3 and the x. I can't just move the x. I can't just be like minus 3. That's not allowed. They are attached. It's like when your friend pulls you to go like to a different, like they pull you to like move in a different area. They like pull your arm doesn't like just detach from your body, right? Like your whole body goes with you. And hopefully they don't pull hard enough for it to detach. But all right, so we have 3x, and I'm going to subtract 3x from that. I have a positive 3x. I'm going to subtract the entire thing, 3x. And I'm going to subtract it to the other side as well because you have to keep it balanced. So 3x minus 3x becomes 0. Positive 3 minus 3 is 0. Okay, so what do I have left on that right side? Well, on this right side, I just have 12 left, positive 12. Well, over here, what happens? If I have 3 minus 3, okay, so 3x minus 3x, what does that equal? What's 3 minus 3? 0x. What's 0 times anything? 0. So really, this equals what? 0. So if I have 3x minus 3x, my answer is 0 here. Okay, well, does 0 equal 12? Is that true? No, it makes literally no sense. So that your answer would be no solution. What does no solution mean? No solution means that no matter what number I plug in for x, this equation will never be true. It will never work out because there's no number on this planet that I could plug in that it would make sense for. So here's a little helpful thing to remember when we're dealing with no solution problems. Let's point to this, because 0 equals 12 makes no sense, right? Like, it's not possible. So if it makes no sense, it is no solution. If it makes no sense, it is no solution, okay? That's how you can kind of remember that. All right, moving on to number 2. So this would be the complete opposite. And this is why it's a special case. Now again, why is number 1 a special case? Well, because in my end answer, I didn't get x equals 5 or x equals negative 2. I got 0 equals 12. And 0 equals 12 makes no sense. Here's another example of a no solution problem. I get 1 equals 4. That is no solution because 1 doesn't equal 4. In the end, if I get 2 equals negative 17, that is also no solution because it makes no sense. If it makes no sense, it's no solution. Moving on to number 2. Okay, first thing I notice, parentheses. Gonna get rid of those. So 2 times x is 2x. 2 times negative 5 is negative 10. And I haven't done anything to this side yet. So I'm going to go ahead and leave that as is. Now, if you look back and just stare at it and look at it for a second, you'll be like, hey, that's the exact same thing on both sides. It's kind of weird. Well, that's actually really important. If you notice that they're exactly the same, I'll go ahead and tell you that you can skip one of these steps. But I'm going to go ahead and keep going, and we'll talk about it in a second. So, goal is to get the variable by itself. So what I like to do is, hey, let's get rid of all the numbers if possible. Combine your like terms if you can. Well, there's 2 ways you could do this. But I'm going to go ahead and start with getting rid of that 10 first. So it doesn't matter which side I want to start with. I'm going to go ahead and start on this side. I'm going to get rid of that negative 10. Now, how do I get rid of minus 10? Well, I do the opposite by adding 10 to both sides. Now, I only have to add it once to the other side. The question is, where do I add it to? Would I add it to the 2x, or would I add it to the negative 10? Hopefully you said negative 10. You're only allowed to combine stuff that are like terms. I am not allowed to do this. This is not allowed. I cannot do that because they are not like terms with each other. They don't have the same variable or same exponent. So on this left side, I have 2x left over because those 10's canceled. And then I have this 2x still. And then negative 10 plus 10 makes 0. So that actually cancels as well. And then what do I notice in this step? 2x equals 2x. Maybe you notice they're exactly the same on both sides again. Interesting. So above here, 2x minus 10, 2x minus 10. They were the same on both sides, both left and right. On the left, I have the same thing on the right, right? And then I notice Then I go down here and I have the same thing again. 2x equals 2x. Interesting, right? All right, let's keep going. Well, next goal is, right, get x by itself, combine them, put them all on one side. So let's go ahead and do that. I like to put my variable on the left, so I'm going to go ahead and move this guy over here. In order to move that 2x to the left, I have to add or subtract. If you want to move things, you have to add or subtract. And because this 2x is positive, I would subtract 2x from both sides. So that would go away. 2x minus 2x, right? So, okay, let's go ahead and do this. This canceled, becomes 0, right? 2x minus 2x canceled, went all the way away, was 0. And my question for you is, what's 2x minus 2x? And the common answer I get is 1. And I'm not really sure how people get 1, because what's 2 minus 2? It is 0. So you want to make sure you do your math correctly here. 2 minus 2, you are subtracting. 2 minus 2 is 0. Then you get 0 equals 0. Does 0 equal 0? Yes, it does. What is that called? Well, this kind of answer is called infinitely many solutions. So this is the opposite of the other special case. Now, you can also shorthand this by saying IMS. For infinitely many solutions. You can shorthand that. But if I ask you what IMS means on a test and you don't know what it means, can't give you credit, right? If I walk up to you and be like, hey, what's IMS mean? You're like, I don't know. I'm like, all right, I'm not going to give you credit because you shouldn't write stuff down that you don't understand, right? So what does this mean? This means that I can plug in any number, any possible number you can think of, 0.5, 1/2, 1.7 billion, right? You can plug in any single number for x and it will be true. That's just the opposite for this one. I can plug in any number I want and it will be no solution. It will never be true. So here it is true. And you're like, okay, how much work do I have to show to prove that it's infinitely many here? Well, if you notice that they're the exact same on both sides, you can actually stop. I'm okay if you want to stop at this step. And you're like, hey, they're the exact same on both sides, infinitely many solutions, IMS. You don't have to write both, by the way. You can just write one if you want. So if you want to write just IMS, you can do that. Let's say you see this step and you're like 2x equals 2x. They're the same. You can stop there if you want. If you want to just keep going, you can stop at 0 equals 0. Another example of infinitely many solutions is 3 equals 3. That's infinitely many solutions because they're the same thing, right? This is different from checking your problem. So at the very beginning, we checked our answers and we got the same thing on both sides. That's checking them. That was like plugging in a number. Here we're not plugging in anything, we're solving. So here, if you get the same thing on both sides, it's infinitely many solutions. If you get two different things that don't equal each other, it makes no sense, it's no solution. We get these two mixed up a lot, so it is important that you do study up these two special cases. All right, we have two problems left. First one is about fractions, and the second one is a word problem that we want to go over so that we are a little bit more understanding of what we need to do for homework and such. So to get rid of fractions, and this is very important because you do have these on your homework and on tests and quizzes and STAR. To get rid of a fraction, you want to multiply everything by the least common multiple. Actually, I'm going to use a different color. This is also known as LCM, least common multiple, okay? Now, what does that mean? Let me give you an example. Let's list multiples of 2. Or let's list multiples of, multiples of 2. So we have 2, 4, 6, 8, 10, ... So this is 2. Let's go ahead and list multiples of 5, okay? 5, 10, 15, 20, 25, and so on, right? So we could literally go on infinitely, but we don't need to. The least common multiple is the smallest number both numbers have in common. So in this case, the least common multiple between 2 and 5 would be 10. That's the smallest number they both have in common. That's their least common multiple. So the least common multiple here is 10 between 2 and 5. This is an example. So I'm going to go ahead and write example. Okay? And I'm going to go ahead and move this because it's kind of far away. All right, so let's actually go and work on the problem. To get rid of fractions, you multiply everything by the least common multiple. This is super useful, so you want to make sure that you do remember this. Now, here I have 1/3 x plus 1/2 x equals 60. You're like, okay, how do I get rid of those fractions then? Okay, you're gonna multiply by the least common multiple. So in order to do that, you're gonna look at the denominators. What's your denominator of this first fraction? 3. What's your denominator of the second fraction? 2. So you wanna list the least common multiples between 2 and 3. So let's go ahead and list multiples of 2. 2, 4, 6, 8, ... You can keep going on and on and on. Multiples of 3. 3, 6, 9, 12, ... I could keep going if I wanted to. The least common multiple is the smallest number they both have in common. The smallest number they both have in common is 6. So that means you're going to multiply everything. And when I mean everything by 6. So I'm going to multiply the whole thing by 6. Okay? The whole thing. So how many things are inside this parentheses? There's 3 terms. There's this, and then there's this. The most common mistake is you will skip one of them. You'll either skip 60 or you're going to skip the middle one. People never really skip this one, but they always skip the middle or that one. It always happens. About a third of the class, fourth of the class always forgets to multiply by something. All right, so we're going to go ahead and multiply everything in. And I'm going to go ahead and do a different color so we see this. So 6 times 1/3. 6 times a third is going to give me 2. So then I have 2x. Okay, 6 times a third. You can actually use Desmos to help you out here. 6 times 1 divided by 3. To write a fraction, I need to do 1 divided by something. So 1 divided by 3, and it gives me 2. Okay, then I do 6 times a half. That would give me 3. So that's going to have 3x. These x's stay here. They don't go away just because you feel like you want to let them go away. Am I done? No, because typically people will say equals 60. And why is this wrong? Because they forgot to multiply it to everything. Anything you do to one thing, you have to do to everything. So 6 times 60. 6 times 60 is going to be 360. All right, moving on. Isn't this a lot prettier to look at than the fractions? Hopefully you agree. So what do I do next? I'm going to go ahead and combine like terms. I have 2x plus 3x. Well, 2x plus 3x is 5x. Oops, that turned that x part into red. So then we have equals 360. How do I get x by itself? What I would do the opposite of 5 multiplying by 5, and I would divide by 5. Oops, there's a dog out there being loud. I'm sorry about that. Dividing by 5. 5 divided by 5 gives me 1, so I have 1x equals 360 divided by 5, which is 72. Okay, so the hardest part about this is thinking about how do I get rid of the fractions. If you don't remember how to get rid of the fractions, you're kind of out of luck and you're going to have to figure out a different way to do it. Is this the only way to solve an equation? No. There's lots of ways to solve an equation, actually. So you don't always have to do one specific way. You could have moved a bunch of different things in a different order than I did, but again, there's lots of different ways to solve something. So to get rid of fractions, you multiply by the least common multiple. And so I'd give you another example here. If I have 1/5 and 2/7, I want to find their least common multiple. I would list the multiples of 5 and 7. So 5, 10, 15, ... 7, 14, 21, ... And I would have to go until I find a number that they both have in common. Now, in order to do this, you always look at the denominators. It doesn't really matter what's in the numerator, so it doesn't matter that there's a 1 and a 2 up there. You want to look at the denominators when you're looking at least common multiple. All right, and we have one problem left. The concession stand has 5 packages of hot dogs, each containing 8 hot dogs. They gave 2 hot dogs to each volunteer and gave away 5 hot dogs for free. After the game, there were 3 hot dogs left. Write and solve an equation to determine the number of volunteers there were. So we have to write an equation and then also solve it. So there's a concession stand. They have 5 packages of hot dogs. They contain 8 each. Okay, so that's important information. There's 5 packages, and they each contain 8 of them. So could I figure out how many hot dogs I have in total here? Well, 5 packages, right? And there's 8 of them in there, 8 in each. Now, that means I could multiply, right? So times 8 in each would be 40 hot dogs. Again, how did I get that? Well, there's 5 packages, there's 8 in each of them, so if I multiplied or I added 8 5 times, I get 40 hot dogs. So I already know that information. They're giving 2 away to each volunteer. Do we know how many volunteers there are? No. So I'm going to go ahead and say X is the number of volunteers. Oops. Remember, this process is called defining your variable. I'm letting the person reading my math know, hey, X is the number of volunteers. It's not just some random number. It means the number of volunteers. I don't know how many volunteers there are, but I do know that they're giving 2 away to each one. So if they're giving 2 away to each one, I could say, hey, maybe 2X, 2 hot dogs per volunteer. And then they gave 5 hot dogs for free. So they just gave them away, it looks like. Gave them away for free. So let's go ahead and set this up. I start off with 40 hot dogs. And then they're giving 2 hot dogs away per volunteer. Minus 2X. They're giving them away. And then, what else do we know? They're giving 5 more away for free. So I'm going to subtract even 5 more. Now, why am I subtracting? I'm giving them away. I'm just literally giving them away because apparently they're just giving them away to people. That's why it's subtraction. You're giving away also to volunteers, so you're also going to subtract that. And then what else? At the very end of the game, there were 3 hot dogs left. So that means that at the very end that I have 3 left over. So how do we get all this information? We start off with 40. You're giving away to 2 to each volunteer. The reason why there's an X attached to the 2 is because we don't know how many volunteers, but we do know that there's 2 for each one. Then we're giving 5 for free. Not for each person, just in general, they gave 5 for free. And at the very end, you have 3 left. So this is going to be our general equation. This is our equation that we started off with. So this is part 1 of our answer because it wants us to write an equation and also solve it. So here's the equation. And now I'm going to solve it. Oh my goodness. So that's the equation part, and I'm going to write. And now I'm going to solve. So 40 minus 2x minus 5 equals 3. Now, goal, as always, is you want to get the variable by itself, but you want to go ahead and combine anything that you can. You know, combine like terms, get the variable by itself by adding or subtracting first. So the first thing I notice is that on one side, I can actually combine like terms. Remember, combining like terms, you can only do that if they are on the same side. If they are not, do not combine them. Like, you cannot combine this 3 with them as well. It's on the opposite side. It's like trying to like combine people into a room when they're in separate rooms, and like you can't just like push them through the wall, right? They have to move outside of that wall or move around that wall. So 40 minus 5 is 35. And then I have minus 2x equals 3. Again, I cannot combine that 3 with the 40 and the negative 5. It's not allowed. But I can combine the 40 and the negative 5 because they're on the same side. Next step here, well, I do want to get rid of that negative 2, but I can't get rid of it yet because I have to get rid of the 35 first. You want to add or subtract before you multiply or divide. So the next thing I'm going to do is I'm going to subtract 35 from both sides. Why am I subtracting? Because this 35 is positive. 35 minus 35 is 0. So then I have negative 2x equals 3 minus 35, which is going to be negative 32. And I'm going to double check this because I just did that in my head and I get nervous with negatives sometimes. Yeah, negative 32. How do I get x by itself? Well, I'm going to go ahead and divide by negative 2 on both sides. Why am I dividing? Because negative 2 is combined to x by multiplication, so I'm going to do the opposite operation by dividing. Negative 2 divided by negative 2 is 1, so I have 1x equals negative 32 divided by negative 2 is going to give me positive 16. So my solution is x equals 16. But what does that really mean? It means that's how many volunteers I have. Because x was equal to the number of volunteers. If x is the number of volunteers, that means I had 6 volunteers. So that is how you would go about solving that problem. Let's go ahead and go over the steps really briefly, and then we'll wrap up this video. So, steps for solving a linear equation. All right? The first thing you want to do is you want to do blank to get rid of the parentheses, and that step is distribute. Okay? You want to distribute to get rid of parentheses. In order to get rid of fractions, you're going to multiply by the least common multiple. Remember, LCM stands for least common multiple to get rid of fractions. If you see fractions, get rid of them. They're nasty. They're going to make it look gross and scary. Don't do it. Okay. If there are like terms, you want to combine like terms all on one side. If they're on the same side, that's important. If they're not on the same side, you can't combine the terms together. All right, now if you want to move variables, if you want to move stuff from side to side, you can only do that by adding or subtracting. okay? And then number 5 is to get rid of a constant. So for example, let me give you an example of what that looks like. If I have 3x minus 6 equals 2, the constant here is the 6. Oops. That's what the constant is. Constant is a number that's by itself. It doesn't have a variable attached to it. So in this case, if I wanted to get rid of the 6, what would I do here? I would add. If I wanted to get rid of this 6, I would subtract. So in order to get rid of a constant, you would add or subtract. And again, you don't have to use these steps, but they are helpful if you look back and you're like, I forgot what thing I should do first. I'm not really sure. And then the last thing, typically at the very end, we either multiply or divide to get the variable alone. I'm not sure why I keep switching colors because I'm using blue the whole time. So you're going to multiply or divide to get the variable alone. If you notice, usually we're dividing at the very end to get that variable at the very end by itself because we divide by -2. Here we divided by 5. So typically multiplying and dividing is usually your last step. Usually, not always. So these are the notes for solving 1 and 2 step equations. I know I went super in depth, but I like to explain, so sorry about that.